some disadvantage. Then we have started the isomerization. Isomerization means that in isomerization, compound having same empirical formula or same composition of the atom, but different in the structural position based upon the structure as well as stereochemistry. We can divide isomerization it into a two category. One is structural isomerization and second is coordinate isomerization. First of all, we will start with structural isomerization. In case of a structural isomerization, compound having same molecular formula or same composition but different in connectivity. Structural connectivity may be differ by different ligand attachment. Then it will be divided into further 5 category. First is linkage, which type of ligand that is attached. In case of a different ligand, in case of a nitro group, if we tell about the nitro ligand, in case of a nitro ligand, two connectivity. One is from that nitrogen and second connectivity oxygen that is connected with the metal. That's why it has connectivity means that is linkage isomer. Linkage isomer. These are the two coordination complex which differ due to coordination to linkage of a nitro with metal. That's why these are known as linkage isomer. Second is coordination isomerization. Coordination means that the coordination bond either it is direct with metal or direct with different ligand. It may be in form of a cationic or anionic complex, but it is does not found in cationic and it is found in neutral that are exchangeable. Chromium ammoniated complex and cobalt anidated complex. If these ligand are exchanged, if it is and this ligand is exchanged here, then these are known coordination isomerization. Means these exchange between the metal. That's why these are known as isomerization. Next is ionization isomerization. Ionization are the isomer which having same structure composition but differ in the ligand that is in the ionization. Means that the ionizable ligand that is having different connectivity. In this case, it is a Br, and if it is inside Br, then compound having same coordination formula, but the attaching ligand that are inside or outside this way, then this is known as ionization isomer. Next is solvate isomerization. Solvate isomerization are the isomer in which any solvent is taken which having the connectivity with the water either in form of a different molecule, like if it is attached with hexahydrated or tetrahydrated, and these are remaining water molecule that come in outside sphere. In this case 2, this 3, and this case whole water molecule are connected inside the coordination sphere. These are solvent isomerization. Next is stereoisomerization. Second category is which having different stereochemistry, compound having same molecular formula, or we can say same coordination complex, but different in connectivity. But different in case of a stereoisomer, different in the stereochemistry. Stereochemistry either in form of a geometrical or optical. In case of a geometrical, it is divided in two types. One is from cis and trans. In case of a number 4 and 6, in case of a square planar, either it is exist in cis or either trans. But in case of a tetrahedral which having no uh, in this case it is exist in complex which having an formula like a metal that is 2x group and 2 ligand L2. Example like a cisplatin and transplatin. In case of these same group attached in same side, these are known as cis. And if group attached in different direction, this and this direction, same group attached in different direction, then it is known as trans. If we take a octahedral, in case of octahedral, the geometry and structure are different, like this way. If it is attached with type of a ligand in same direction, like this and this, both are in opposite direction. But in this case, these same ligand that attach in same direction means these known as cis isomer. You only listen about these isomer in 11, 12. Next is if bidentate ligand, bidentate means which has two donating side, like a ethylene diamine. Ethylene diamine has two, like a one is from here, second is from here, and 2, 4, 5, and is octahedral complex, same ligand. These same ligand attach in same direction means it is cis. But this case it is attached in one direction, second is attached in this direction. That's why it is known as trans isomer. And then we can divide it the optical isomer. What is optical isomer? Enantiomer are a mirror image that superimposed on one another, means that has no opposable mirror image exists having an chiral center. Either it is dextro or leo. Dextro means that rotates polarized light in an clockwise direction. That's why it is known as dextro. It is levo. Levo means the plane polarized light that rotated in left side. We can say anti-clockwise. That is known as levo compound. These are the some complex which having some activity. In case of octahedral complex, either rotated in D direction or L direction. Base structure, if it is rotated in clockwise direction, as that complex. And if it is rotated is anti-clockwise direction, then it is known as levo complex. These are all about isomerization. And we will come to next theory, that is VBT. Next is VBT. Then there are a different first theory come is Warner. Then there are some theory. It does not explain the why the complex and different type of an hybridization. It does not explain the color as well as magnetic and optical property. Also, it does not explain about the directional of an bond, means whether it is form an sp2, sp3, or which type of an complex. Then we can come to into VBT. First, that theory was given. Then next theory is VBT. According to this theory, that was given by polling scientists that can utilize the hybridization of a metal with which can accept the lone pair of electron and different connectivity with an ligand that can give different open shape as well as structure on the hybridization. And what is hybridization? Hybridization is the mixing of an atomic orbital. If we take an example of any complex which having six ligand that is attached, like a cobalt 6 hydrated plus 3 complex that having an 3d6, means that 3d orbital that is filled according to energy, according to the electron fill one by one, then fill in the electron are filling according to its energy level. In case of a the total is 6 electron that is filling. After that 4s, 4p and 4d. These 4s, 4p, 4d are orbital. In case of a ground state, after that it is going in excited state, means that electron is transferred to s. Then that ligand, 6 ligand that is attached here, based upon the ligand attachment, that can give hybridization which having lone pair of electron or either in form of a coordination or overlapping with the vacant p orbital or p orbital. Based upon this, we can divide the complex it into a high spin complex or low spin complex. And if it is a low spin, and if where it is high spin, how we distinguish low spin and high spin based upon the structure. If it has hybridization in d orbital, means d orbital there are two probability. One is this one, second this one. In this case, it is forming dsp3 hybridization, but in this case it is sp3 d2. Means d orbital that is internally participating the electron that can give inner orbital complex, mean inner, these are the six electron in cobalt 3, means total 6 electron that is opposite filling. That's why it is known as inner orbital. That lone pair of electrons shift from d to s or p, then it is known as sp3 d2. This type of a complex which having high spin and which having some paramagnetic nature. In this case, it is it has no paramagnetic nature. It is an diamagnetic because it has no unpaired electron. It is a filled. Completely filled means that having that these electron are paired up. paired up means there are no unpaired electron. That's why it inner orbital which having low spin complex. In same case, if we come hydral complex like in case of a nickel chloride 4 2 minus this complex. In case of a nickel, it is a D8. D8 means total 8 electron in d orbital. 8 total 1, 2, 3, 4, 5, 6, 7, and 8. Total electron are filling, and S and P are vacant. Then these electrons are participating, and these electrons are with that chloride ligand, these chloride ligand, and these chloride ligand forming a different structure which having an sp3 hybridization, having a tetra. If d if participation of that d orbital in this cell means that electron are inner sphere. Inner sphere means that are paired up, and d orbital is participating in and bonding that can form a planar. In case of an if it has charge on that metal, that can give a different complex, whether it is a square planar or tetrahedral. Then how we will distinguish which type of a complex is formed? It is a square planar on the structure, because all have tetrahedral and square planar both 4 ligand attached, means one is from sp3 and second is from dsp2. How we will distinguish? And it does not explain it nickel chloride 4 2 minus forming a tetrahedral, but in case of a TCl4 2 minus that forming a square planar. Why complex forming different shape? Because all have 4 ligand that is attached. Based upon this theory, it has some controversy. That's why next theory come, that is CFT, crystal field theory. Crystal field theory that explain why that platinum complex forms square and that nickel complex forming a tetrahedral complex. And it also does not explain the color, that color, also the spectra of the complex, how these spectra will come, and the magnetic moment are not exactly that is reported in the literature. That's why next theory come into play is CFT, crystal field theory. That theory was given by Hans Beck, and next scientist is Van in 1999, and based on the assumption that and ligand act as a point charge, means metal are attracting to ligand which having some point charge, and there are some type of an electrostatics interaction, means is a some type of electrostatic interaction, means if some type of a point charge means some type of attraction. Attraction means that can create positive and negative charge. That can create positive and negative charge, means metal exists in form of a positive charge and ligand exists in form of a neutral or negative charge, means they are positive and negative interaction, means positive and negative interaction type of attractive force, or we can say electrostatics, means attraction force are more as compared to repulsive force. That's why there are the electrostatic interaction in a complex that can create a charge in the complex. And such interaction, based upon such interaction, there is uh, some type of an we can say stabilization, and these stabilization can split the orbital it into a different orbital, different orbital based upon the splitting, and these thing based upon the charge, how much charge on metal and how much charge on a ligand. That's why the theory CFT means crystal theory. There is some point between the either exist in positive charge, some type of a neutral charge. But in case of a ligand, either it is negative charge or some type of an existence. That's why they create a electrostatic attraction, and that electrostatic attraction that can split the orbital into different energy level and give different type of high vibration. Like in case of a d orbital, if it is d orbital, that can stabilize and means some point charge here in d orbital, and that can stabilize with a negative charge that can decrease the energy. After that, there is some type of repulsion between the another, like a sp and vacant d orbital. That's why the energy slightly increase this, and then there is some type of disturbance due to repulsion of a d orbital with the ligand, and disturbance can give the energy gap. That energy barrier split energy, split energy based upon the d orbitation. It can split according to how much d orbital in the orbital. When a complex has some degenerates to a 5 orbital or 4 orbital, or we can say it is exist in square planar, tetrahedral or octahedral. Based upon these different d orbital orientation, it can split it into a different energy level. If d having a different shape orientation like this way, if metal that is attached with a filled octahedral complex, in this case like a total six ligand that is attached, and which having no spherical field, that's why this degenerate according to its d orbital occupancy, and these electron along with these exits are split like this way. In case of a d orbital, there are a two probability, either it exists in dxy dyz dxz in a three, and second is dx square minus y square, and that's why there are a probability, either it is no, it is 2g d dyz dxz, and these are the dx minus y square and the level, and T2Z and EZ both having different energy, it energy as compared to this one. So the splitting in case of an octa, in case of octahedral, having a more electron which is more stable, and these are split to spherical symmetric field, and that has two probability, either is it is split it into one, this dxy dyz dxz, these are known as T2G level, and second one, this is dx square minus y square dz square, these are easy level, easy level, sorry, and these T2G and level has different configuration based upon the. Yes, any doubt? Please raise your hand if you have any doubt. Sir, please. Okay. Actually, you have already studied the VBT. That's why I have go through the VBT, not discuss in detailed. Syllabus mainly focus on CFT coordination. But I have go through the basic from your 11 12 because in 11 12 you have discussed you have already the VBT as well as isomerization. In case of a in case of CFT, in case of a octahedral complex, it is two orbital. One is T2G and second is E. Because these dxy divided dxz has same symmetry, that's why it is known as T2G. And these dx square minus y square dz square has same symmetry, that is it is known as easy level. And these are split according to its energy level. And these can be connected. These T2G has lower energy as compared to easy level. Based upon these, it is a energy profile diagram, or we can crystal field splitting in octahedral field. In this case, octahedral field, there are a d orbital that it easy, and these energy level, these are the energy level to maintain, these are the energy level from that, this is the barycenter, and from that barycenter to easy level is 0.6 octahedral, and from bottom this is the 0 point, we can say octahedral energy, and from this point to T2G point, this is minus 0.4 Dalo. And based upon this we can divide it and stabilize the orbital according to its energy level. It is shifted toward easy level, means it is in a 0.6 ratio, but in this case it is a minus 0.4 Dalo. That can give the splitting energy. But in case of a tetrahedral, it is existent. It is exist either in form of a dx square minus y square or dz square, because these lobe are touching with that face. In case of a dz square, the shape is look this having an orientation toward z axis. But in case of a dx square minus y square, the orientation of an x and y in form of an x and y direction are perpendicular to each other. That's why these lobes are touching with that surface. But in case of a dxy, no touch with that x and y, because in this case the lobe of that are not touching with that x and y axis. And the angle in this case is the normal octahedral bond angle, that is tetrahedral bond angle. That bond angle is 109.28 divided by 2 means total, we can say total is 54.44 angle. But in case of an, we can say T2Z, the central metal that is attached with a bond angle is 35.16. These are the bond angle found in case of an tetrahedral T2Z and EZ. In case of an EZ level, the bond angle is 54.44, and in case of an, we can say T2Z orbital, 35.16, and the T2Z orbital are near that direction that is attached with ligand than EZ level, and the energy rays are more because they are close towards the that particular ligand that is attached with the metal, and these are the attaching with either in form of a T2Z or EZ level, and these energy level are very closer to each other. But in case of a tetrahedral, it is in reverse. Reverse means that easy level are more oriented toward that xy plane, means it has lower energy dx square minus y square and dz square, and these three dxy divided dxz has higher energy, means it is a 0.4 del t, and these are minus 0.6 del t, and the total energy gap is del t. Total energy gap between these EZ and T2Z is del T. Total is minus 0.4 del T minus 0.6 del T. In this case, these are the one type of an tetrahedral complex. Next is, you can say, square planar. The geometry octahedral and tetrahedral. In case of an octahedral, T2 is lower, means that XY plane that is oriented toward X has lower energy as compared to dx square minus y square and d square plane. But in case of an tetrahedral, dx square minus y square has lower energy as compared to T2Z plane. These are the in case of a 0.4, 0.6. In this case, 0.6 for del T. These are the some scenario in this diagram of tetrahedral and hydral field with different splitting. But in case of a square planar, the split particular axis is dz square. Dz square means that dz square is participating in bonding because its orientation does not meet with x and y. That's why dz square has lower energy that can participating in bonding. These are the d orbital. These can split it into a two T2 EZ, and T2Z has two configuration, either dxy and dyz. Second, it is further split dxy, but that easy level is further split it into a dz square and dx square minus y square. These energies there, and total energy in square planar complex is slightly higher as compared to octahedral as well as tetrahedral complex. If allowed, please write in chat box. In today class, we have discussed about the isomerization. Isomerization means compound having same formula or same connectivity, complex having same formula but different in the connectivity. Based upon the isomerization, it can be divided into two categories. First is structural, second is stereoisomer. In case of a structural isomer, it can be further divided into 4 or 5 categories, either in form of a solvo isomerization or ligand isomerization. These are the different type of a isomerization. Then stereoisomer, which having different optical connectivity, either it is form of existence or trans. Then we have the disadvantage of a Warner theory. In case of a Warner theory, it does not explain the hybridization as well as the color and spectral property of the complex. That's why next theory come into play, that VBT, valence bond theory, that is discovered by the scientist Pauling, and based upon this theory, it is similar as that of a covalent theory, and this theory tells about the different complex forming and different hybridization, but it does not explain how we will distinguish between the square planar complex and tetrahedral complex. Also, this theory does not explain the magnetic moment and color of the complex, and based upon this VBT we divided the complex into a two category. One is low spin complex, second is high spin complex, and that's why next theory come, that is CFT, crystal field theory. According to crystal field theory, it is complex is an point charge. Point charge means there are metal and ligand that has some interaction. Interaction means that can split the orbital it into a different orbital. Based upon the splitting, it can give different type of spectra or different type of an hybridization. And we have discussed three type of an splitting. One is case of an octahedral. In case of an octahedral, tetrahedral. In case of an octahedral, that del and del 6. In case of this one, and in case of a tetrahedral, it is look like this one. And then square planar, that T2Z and easily split up it into a two, and these are the T2Z that can split into a two, dxz and dyz. Next is dxy, slightly higher energy because it is oriented toward an x. If you doubt, please write in chat box. Yes, after completion, I will share the notes. Your offline class is starts from, I think, 24, na? Sorry, 14, na? from 14. Okay. Okay then. Okay, thank you so much. If you have any doubt, please write in box. Otherwise, we will end the class. We will end the class.